Hello everyone, I hope you're all well. I'm going to be walking you through an integration by substitution question. I'd recommend you to pause the video now and attempt the question yourself. So the first thing I'm going to do is I'm going to rewrite out the integral over here. And they've given us the substitution x equals sine theta. So we're going to want to differentiate this. When we differentiate sine theta, we get cosine theta. Now we're going to rearrange it so that dx is the subject, so that we can substitute it and we can solve the integral in terms of theta. So that'll be dx equals cos theta d theta. And now let's sub it into the integral. So we know we have the substitution x equals sine theta, so we can just sub in sine theta for this and we'll get 1 minus sine squared theta. I think you can see where this part is going. Times by cos theta d theta. When you see the denominator over here, you should be reminded of the trigonometric identity cos squared theta plus sine squared theta equals 1. And of course, when we rearrange that to make cos squared theta the subject, we get 1 minus sine squared theta. So we can substitute cos squared theta into the brackets over here. So we will get the limits 1 over cos squared theta 3 over 2 multiplied by cos theta d theta. And when we expand the brackets out, we'll just get 1 over cos cubed theta, because 2 times by 3 over 2 is 3. So that'll be 1 over cos cubed theta multiplied by cos theta d theta. So cos theta here will cancel out, and this will become cos squared theta, because the cos thetas will cancel each other. So we'll get 1 over cos squared theta d theta. So we have to remember that these limits are actually in terms of x, so we have to convert these limits so that they're in terms of theta, because we've substituted in terms of theta. So we remember that our substitution was x equals sine theta. We know that x equals a half, so sine theta is also equal to half, so we'll do the inverse function and we'll get which is pi over 6, and 0 equals sine theta. We'll apply the inverse function on that and we'll get 0. So the limits will be pi over 6 and 0, 1 over cos squared theta d theta. I think it's at this point where lots of people get stuck, as in they don't know what to do with this further. But we should remember that 1 over cos theta is the same as sec theta. Therefore, 1 over cos squared theta is the same as sec squared theta. So we can write this as the integral sec squared theta d theta. And when we integrate sec squared theta, we get tan theta, because we know that tan theta, or when we differentiate tan theta, we get sec squared theta. If you don't know this should be in your formula book. I know it's in the formula book for AQA, which makes it easier for us, but I'm not sure if that's the same case for other exam boards. So it's better to probably memorize it or to know it by heart. So when we integrate that, we will get pi over 6 and 0 as our limits, and tan theta. No constant because it's definite integration. So now we can just substitute pi over 6 in and 0. That's going to be root 3 over 3 minus 0, which equals root 3 over 3. Therefore, the answer to this question is root 3 over 3. I hope you found this video useful. Thank you for watching.